habe ich gesagt, er bringt die Pizza auf jeden Fall auf den Punkt, sonst ist sie kalt. Das war dann unser Fehler, wir haben es ein bisschen zu lang gezogen, aber ich hoffe, sie hat trotzdem geschmeckt. So, jetzt also, der Titel ist viel zu lang, als dass ich ihn mir hätte merken können. Ich wollte nur kurz mal sagen, das ist nämlich, es ist folgendermaßen, vor 2019 vielleicht, war hier ein Data Science Meetup, er stand hier rum, gesagt, Blue Yonder, macht ihr auch Masterarbeiten? Ich glaube, das war deine Frage. Meine Antwort war wahrscheinlich sowas wie, keine Ahnung.
Die Antwort war wirklich, wir wollten das schon immer mal machen.
Ja, so bin ich, gell? Übertrieben ein bisschen. Nee, es hat aber tatsächlich funktioniert. Du hast, glaube ich, die Masterarbeit gemacht.
Ja.
Und offensichtlich gar nicht so doof angestellt. Jedenfalls bist du tatsächlich da mittlerweile bei Blue Yonder gelandet. Und dann haben wir gesagt, naja, gibt es einen Freiwilligen für einen Talk heute?
People from our international audience asking what's the language you speak.
Okay. I should switch. That's right. And we didn't choose just a very easy topic, right? So since he just joined, maybe 2020 then,
Yes.
right before the pandemic. So we said, okay, you do the talk about 10 years of operating machine learning-driven applications at Blue Yonder. So he had to soak up all the knowledge of the experts, and I hope you got it, all of it, because now you have to present it. So, welcome.
Okay, so welcome to my talk, Operating an AI/ML-driven product at scale for 10 plus years. And I will just start copying the seasoned speaker with saying I will do talks from now. So let's hop right into it. This talk will not be about data science or data scientists as a focus, but we will shine the spotlight on the other teams that are enabling us to run our systems and our product as we do. And I will start with a small little about us, just a few slides to show to you why we are, or what enables us to be able to be in the position to speak about this in the first place. So we here at Blue Yonder, the venue, we are the company that is presenting the venue today. We are in the supply chain sector, and our mission is the automation of the supply chain. And I'm a data scientist, as Sebastian just introduced me, and I'm from the LDE, the Luminate Demand Edge team. And what we are doing is we are providing for the retail sector demand forecasts. So we have the supply chain from the supplier to the distribution centers to the actual stores. And our solution, the Demand Edge, is giving the customers, the entire retailers with their global or regional structures, we are giving them or providing them the forecast which products will be sold in the stores at what amounts. And we are running all of this fully automated or AI solution fully automated with some key KPIs. I will come back to these later, but just to grasp the scale, which is what we are talking about today, is that our systems, or largest customer system, can run 500 million forecasts in 10 minutes, which is relevant to us because the customers expect their forecasts for the large organizations every night, and the sooner that we get the forecast out to the customer, the better, because they can start ordering sooner and they will not run into restocking issues, because in the supply chain, if you are delayed at the very end, you will get like enhanced effects to as we said, as we've seen earlier, you will get more delays to the left side because each and every single link in the chain will pass the problems through. And just the scale of the entire system, so across all of our systems. This is a little bit of a dated number from 2022, but every quarter we are running, then we have grown since then, but we have run 7 trillion predictions in one quarter. So yeah, like our product is supplying a lot of known names, and we are talking today about how we ended up here, and what steps in the way, at what steps in the way here we stumbled up the mountain. But first, the last slide about our company. So we have started very adjacent to the Karlsruhe University in a small company called PhyT, Physics and Technology. And from that was born the German company Blue Yonder. We were acquired right before I actually joined, so in 2019, by a large company named JDA. It's about, or back then it was around 5,000 employees. And yeah, then we played some Uno reverse card, and actually we acquired them, like the 200 people up. Not really, but yeah, nowadays we are Panasonic owned, but a separate organization subsidiary. Okay, but now let's get into the talk. Having talked about the numbers, I'll push them first. So our success journey and our success recipe. So as many other small companies, as said, we started small. The first objective is winning some customers, providing them some custom solutions, and without really having an identity yet. So just a customer has a problem, you provide a solution to solve the problem, and growing, while growing, the customer, the solution needs to start to scale. So you're trying to consolidate some custom solutions, and in the end, you're trying to build a product identity or establish a product identity. But at some point, when you really start hitting some problems and you really start to have to scale your company, because your name gets known and more customers will try to get your solutions because you're getting values to their competitors, you really have to push and start to establish a clear identity for your product. And this is something we are established in our segment, and the core the core ingredient in our recipe has turned out to be that we are operating our system very close to the data scientist. So many other companies that are starting to scale their solution will have a data science team and some operations team, and these are separated. So you start to move the data away from the scientists. So sooner or later, those companies run into issues where the scientists are too far from the data. So we have actually our success recipe, as that is, we as a data science team are actually operating the entire system as the data science team. So I, as a data scientist, am developing my solution or the stories, the new project, the new enhancements, and I get it all the way to production, which is decreasing the time that the turnaround time of recognizing errors. We are having fast iteration cycles, working right on the data, and it improves us, or it gives us the ability to ship our improvements timely, because we are directly pushing our changes to production. So the big requirements is mainly in time. So when we are operating our systems, we cannot develop them. So the two big branches are on the one side that we have to be able to operate to develop new systems unimpaired by the operations. So we have to decrease the amount of time we are spending on operations. On the other side, part of the operation is also the customer interaction. So by scaling down the need for the customer to interact with us and the need for us to interact with other systems, we can focus more on the development of our software. So from here on, I will focus on the segment automation, customer enablement, and standardization. Of course, standardization. Starting with automation, our entire system is running completely automated from A to Z. So if nothing goes wrong, we do not have at any point any need to interact with the system after we have configured the system for the given customer. We have complete alerting separately for the dev team and also for our support teams underneath to be able to operate the system at scale. Our deployment is completely automated, and we also have automated our entire development process, and I will show this later. For the section of customer enablement, we have invested a lot in a powerful AI assisting UI, assisting us data scientists by giving the customer the ability to access their data directly, automated, understand their forecast, analyze the quality of their forecast themselves, and they can even interact with the forecast we are giving them by issuing overrides, for example. So the customer, we are enabling the customer to not have to interact with us, but to actually have a faster way to interact with our predictions themselves with our powerful UI. And the most important thing that our UI is providing us as a development team in the end is if there is a problem with the system that the customer really has to ask us about, because it is a problem in the model, it serves as one central interface for both the customer to be able to send or to show us what is the problem, and us to report back to them and also share, for example, a link to our UI with a new analysis to share them what they are misconstruing about the situation, or to give them additional information of what is actually wrong. So we had a lot of problems in the past where the customers, like every customer has different systems, so they're just sending some CSV file, and you have to spend hours to first get what they're actually going or getting at before being able to start with your analysis in the first place. So this is why our powerful AI is one core part in the chain for us to be able to operate our systems. And then the last big sector is standardization. Of course, like custom solutions cannot be operated at scale. So I will be talking again about features, technologies, and our powerful platform, which is actually a big part of enabling us to operate and develop at the same time. So let's just go a little bit over this. So you can see we actually have proof that we started out as a very small company. So we started out with this as our backend, with our custom solutions. We grew, and one big problem with growing and scaling a product that has started with custom solution is that the customers also got some custom features. And at some point, you're consolidating your software, and you're still providing compatibility to all these custom features because the customers, they want it. But at some point, you will not be able to scale this anymore. So there will be a point in time where you have to have built enough trust with the customer to be able to discontinue some features and compel them to take the step with you by providing them a lot of value on other sides with the improvements that you will make to the system once you are able to scale the system on the other side. Then the next one of the very central enablers for us to be able, as data scientists, to be able to operate our own systems is our proprietary platform. So we are calling it Stratosphere, which is started out as we have seen before, with just some PCs taped together in the basement. And very early we started scaling. So again, in this basement, we set up our own calculating resources. And finally, we started to Microsoft Azure. But we as data scientists, we do not actually have to care or to interact with Azure at all, because we are interacting with our own proprietary platform, which is abstracting resources in standardized ways that we can plan our processes around. And one big thing is that even Azure has sometimes problems, has clusters going down, has wide-ranging problems that can be solved if you have a lot of expertise with handling these problems. And this one single platform enables us to, as data scientists, not have the knowledge, have to have the knowledge to handle these platform or these resource incidents, because we have a different team that we can hand these problems to, while still being able to push forward with iterating upon the machine learning model and operate our systems on the other side. So the platform is one of the biggest reasons why we as a data science team can actually operate our software at the same time, because this is a lot of knowledge and a lot of expertise that we can just hand to this team. Also, it provides us a lot of economics of scale, because as I said, like right now, it started out with LDE being one of the largest products on this platform, and there were a lot of improvements and requirements that have been implemented and served to us, which is now also providing the same benefits to new products in the company that are currently being migrated onto this platform. The last or the next big reason why we have our own platform is, as coming back to the two numbers before, if we can run 500 million predictions on one system in 10 minutes, this means that we can almost run our entire workload on one system. But we have a lot of different systems for different customers deployed at the same time. So the resource demand that we have, as we said, we are calculating during the night time, is very spiky and very sparse. So Stratosphere actually gives us the ability to pool these resources and distribute and balance these resources across our computing workloads that we, again, as data science team, do not have to care about. This is something that is provided out of the box by our platform team. Okay, so as said again, because we are talking about the last 10 years, there has been quite some iteration and just like a little visualization where the platform has come from and moved to. So we can see that it actually looks dated, and it does the next iteration. So right now we are on Stratosphere 10. This is somewhere in between, and it still looks dated. But we can actually see, if we look at the format, that we already have some project and some recognizable systems running, which is something that the latest version also, it looks a little bit better now. It looks a little bit less dated, and a lot of things have changed. A lot of capabilities have been added, but in the end, we have grown with the platform has grown with us and enabled us to run our processes as we desire. And both the backend and Stratosphere have progressed in time, even visually. A very small slide, just to mention, coming back to what Peter said at the very start of this event, that we are doing data science since it was called statistics. So back then, it wasn't actually, Python wasn't necessarily the standard to solve these problems. So during the years, we had to migrate from self-implemented basic versions of pandas and Dask, for example, or Spark distributed implementations of frameworks that are given today, but that have not existed back in the day. So this is a big thing that you have to adapt to the shifting technological landscape at all times. And another story that is happening right now is that at some point, because we have all of these simultaneous workloads, especially in our evaluation processes, because as said, we can actually run our evaluations on all customer systems. So if we run a global evaluation, there's a lot of systems that are querying the data at the same time. So we in the past, coming from or querying the data directly from databases had us impede our development processes. So in the meantime, we moved away from querying data from the database, but we actually put the data down to the file system in some in packets or stored in some blob stores. Querying it from there had us enabled us to have more parallel workload on these systems. But technology have moved forward, and right now we are running a initiative to move everything back to the database again on Snowflake. So yeah, like even if you have a good solution at one point, the technological landscape is shifting, and you have to keep up and maybe even move back what you did before. In terms of automation, this is just some screenshots from Airflow. Airflow is the service that we are using to orchestrate all of our productive systems. And we actually moved from the start, like we started off small, as said, and we had a lot of manual triggers for a lot of processes, and this is now fully automated. I mentioned it earlier, but nowadays we only have an initial configuration effort for new customer systems. And everything from that on, as long as there are no incident situations, is running from A to Z completely automated. So from data ingestion from the customer over us managing the data, running our trainings, our predictions, to providing the data back to the customer is running fully automated. And automation is just, or like the initial automation is just the first step. But we ran into a lot of problems with actually managing the incidents and the systems failing. So ever since, we have always increased and expanded our processes and our system with additional retries, with some recovery, some process recovery. So for example, in our training, if the training is triggered here, if it is failing in our wait task, we actually have another loop with some recovery function to trigger it again, to just try again. Because if this is just some fluke happening, if this is a networking problem, the system will recover itself, and it will decrease the amount of interaction that we have into the system if it can recover itself. And if everything goes south, to put it like this, we also have fallback mechanisms. So the system is actually able to provide previously achieved predictions to the customer in some fallback functions. So it is taking pressure from us as the data science team, as the operating team, to act at the very time that the incident is happening, because we have fallback functions covering our losses in some cases. Now on to like away from the operation part and onto the part that I mentioned, that what is the advantage of having the data very close to the data scientist. It is our ability to test all of our changes. So every single change that we can do can be run on any customer system. So if like some customers have in their sales data very different patterns than others. So some customers have some problems with their predictions that others don't. And if we design a change to the model, if we try to fix the problem, we can run with just the click of one button. With the GitHub action, we can run the test for the system on some limited scopes with one click on any system, on all systems. And right behind this, we have a lot of reporting or automated reporting. So once we are triggering our evaluation functions with one click, there will be hundreds of pages of PDF reports about these changes. What is the impact of my change will automatically be generated. And this is something we have spent a lot of time perfecting. And this is something that is really increasing our time to iterate upon changes and really see in a very short amount of time, has my change worked, where have other places, like in data science or with a machine learning model, if it changes at one point, it's safe to say that something is breaking on another side, maybe. So we have global reports and ranking of error cases where we can actually see if something is breaking on one side and we fix it, but it's breaking more on the other side, it will be caught here and will be put to our attention. Part of these reports is also, this is an example where Blue Yonder is currently saving Christmas. So Christmas is a very tumultuous time for us because it's one of the biggest events for many of the retail customers. And we can see here, so a little bit of a legend. So this is just the zoom in of the effect we can see here. But the green dots is the sales that we are trying to predict. The master state, so the problematic state, was the orange line. And the candidate state is the branch that we have just triggered our evaluation on. We can see here directly after having pressed one button that my change has worked or my change has not worked. And this is on customer data, on live data at real time. Also, it's not just, as said, we cannot just evaluate one system. But fixing or changing the system at one point can have very harsh consequences for other customers, for example. And all of our evaluation mechanisms is also global or can be global if we trigger all systems. But we have also some meta-analysis reporting to see how our changes are affecting the entire system and all customers. So we had to redact the customers, but these are different customer systems and different comparisons from the main state and your candidate branch state, for example. So going away from automation and from our development cycle over to our UI side. So the UI, as mentioned earlier, is something we have spent a lot of time and a lot of effort we put into it, because at some point in time or back in the day, sometimes there was a little bit of a sentiment to limit the amount of data we want to show to the customer, because if the customer sees less problems, we have less service requests or they are raising less issues to us. But this is something that we really recognize that we had to change because the customers, the uncertainty just rose, and they were putting more and more service requests out to us, which was limiting our ability to push the system so forward. So we went from some notebooks, some IPython notebook analysis and some PDF analysis to a fully automated UI system. We have now reached a point where basically 80% of what we are looking at in our internal tooling is also visible by the customer and also represented on the UI. So we are really enabling the customer to see that their forecast, to analyze the forecast, and to gauge the quality of their forecast at the same time. And we have really recognized that the customer understanding what they are getting with us and what kind of issues is actually also coming from their own data quality issues and their own limitations of the data that they are sending to us has really relieved a lot of pressure from incoming customer requests and just the amount of incidents that the customers were raising with us. So the UI is now functioning not as an analysis tool just for the customer as well, but since we have all this capability on the UI, if the customer is raising an incident with some screenshot of our UI, which is the only, as I said earlier, like the UI is now the sole interface that we are accepting for service requests, because we will not be looking at CSV files that they are sending to us anymore. So they will send us a screenshot of our UI, and because of all these capabilities, most of the time we can actually just go through the UI ourselves and already respond with the problem that we are seeing without us having to actually go back to our internal tooling and reconstructing the situation. And yeah, this has really decreased the turnaround on our service requests and then our customer interactions a lot. Another big thing is that the UI is not only capable, or the customer not only capable to analyze their problems on the UI or their forecast, but they are actually also able to manipulate the forecast. So we have the option. This is something that the customers were really requiring from us, that they want to have the power to override a problem that they are seeing, because problems are happening if you are putting out billions of predictions. So we have, as part of the UI, we have this override service. So the customer has the power to override everything. As said, the customer feels very strongly about this, and this is something that they really want because it gives them control. But last year we actually ran a scientific we ran a test on whether the overrides that the customer is issuing is actually adding them value. And we have found that most of the time when the customer is interacting with the system, they're actually making it worse. So it is something that the customer really wants. But in the end, this is probably something up to debate in the future, because it is an homage to our automation and our systems working better than the experts that are interacting with the system afterwards. And another very big point for the customer side of operations, alleviating a lot of stress from us, is having built a customer support structure that is interacting. So we came from a position, actually, even in the last 3 years when I started, I still had a Salesforce account. So we came from a position where we were directly interacting with the customer with their requests, to building an entire support structure beneath us with, at the start, scripted solutions. But we have really started educating them, and they are really educating themselves as well, to fence off a lot of the incoming requests with their expertise already as well. So again, this is a large part of operational workload that we do not have to contend with anymore as a data scientist team. So we are moving more and more to a state where we are just reaping the rewards of being close to the data, but not having a lot of the drawbacks anymore that we saw in the past from operating it at the same time. Okay, and because it's in the title, we have to finish with successes, failures, and learnings. So outright successes is mainly, as I said, the platform. This is something that we have profited from the very start, and we have never looked back, and actually the entire company. So as I said, we have been acquired by JDA in the past, and the platform was already something that existed then. And more systems in the entire big company now are moving onto the platform. So this is really a success story. Then as said, we have never doubted automating all of our systems. So this has just been a success story from the start. And yeah, the little bit of standardization that I mentioned, but there's a lot more of standardization that we were conducting in the system. So these are just success stories. And yeah, failures and learnings. So some points where we, in our journey, where we have stumbled up the hill is first that we tried the approach of operating the system away from the development teams, and we have not been able to, or it has hit a lot of the problems with impeding us in going forward, not being able to work on the data as closely, for example. So this is something that is really a big point I want to bring to you, that this helped us a lot, and this is something that has a lot of learning in it. Then again, the first approach of fencing information and some analysis tooling away from the customer with the fear of the customer overwhelming us with seeing problems was completely the wrong direction. So we have made the experience that giving the customer more capabilities to analyze the problems is actually making it better, because they can educate themselves more and get more adjusted to your system and what is actually going wrong, rather than just thinking something is going wrong, not having the information to analyze where it's coming from. Then at the start, the insufficient investment in the other support structure, fencing or first filtering the data for the data science team is something that we have iterated on a lot and is now helping us a lot with not having to interact with the service requests as a development team anymore, or as an operating team. And yeah, like in the end, at some points we have accepted some interactions with the system, but we have found out very fast that full automation is the way to go. So this is one of the largest and last points that I want to mention here. So just a little bit of a finishing plug. Yeah, we are currently really searching for data engineers, data scientists, and software engineers that want to expand upon our system, expand our automation, improve our forecasts. And we might not have the fitting position on our career side, but Peter is happy to just receive an email from you. So feel free to spam him a little bit. Yeah, and that's all I have to say today.
Are there any questions?
So Sebastian, what was the biggest fuck-up that you delivered to a store? do you remember this beer incident?
The good thing is I was never really involved in those customer projects. So I was in the platform from early on. So and I did a better service. So but yeah, we had some incidents, right? So there was one store which was at some point fully packed with beer. So every floor was. Yeah, it was a problem. I don't exactly know what the real issue was, but it was a data problem from the customer, so it wasn't really our fault. But yeah, there was a lot of beer.
Yeah, but that's a good point. I think about supporting the user with generative AI. So the input data
Oh.
What we really try to do is a lot of, if you automate the system, you also want to steer the customer to focus on really things where he can have a large impact. And that's where we are using large language model or trying it out. Yeah? Can we guide him to the right exceptions?
Okay.
So that the power user on the customer side is guided to, I don't know, high-level variations and only looks at stuff where he really can add value. That's what we're trying out. And we also try to basically learn from user interactions. Yeah? So this overrides, we did an analysis, we have seen, okay, they make it worse. Then we try to give them hints and try to separate the cases where they make things worse. Yeah? To guide them and again and say, in the past we have seen you have done this and this and this, it didn't help, maybe you shouldn't do it this time. So that's what we are trying out. We are putting it on the marketing slides that we are doing it in production actually, but it's still a long way to go for us.
Yeah. Any more questions over there?
So I have a question, so this may be also again to Peter, because it's dealing with the early days. What was the reason to move to Microsoft Azure? Why not Google Cloud, for example?
Yeah, so basically we did an analysis. Technically it would have all been possible. Then we talked to our customers and they told us if you go to AWS, direct competitor of every retailer, we will never do business with you. So AWS was out. And then we talked with Google, and I don't know if you have experience with Google customer support. So did you ever got a real person on some Google issue? Never. Yeah, so Google sucks at customer support. And they also suck at enterprise customer support. And that was really the reason for us. Is this streamed? No, so that's
The stream is off because YouTube belongs to Google.
Yeah. They have brilliant engineers and I think also very brilliant software that you can use there. But as an enterprise customers, it's so hard to interact with them because they always think they are the only geniuses in the planet. This was really a reason for us where Microsoft, yeah, coming from enterprise software, maybe not offering the best cloud service. Today it's fairly okay, but really also the support, and you need this support. If you depend on a cloud provider, you need to get support there if you can't help yourself. And that was, back in the days, one of the reasons then to go to Azure.
Yeah, I can even add, over some years the CTO back then was like, yeah, we wrote to AWS, they said here's 100,000 euros credits, try it out. Azure was like, okay, we send you 5 developers over, we fly them in, they sit together with you, they build it with you. And Google was, we don't understand, the prices are on the homepage. So what are you talking about? So that's the difference, and probably that was the reason why Azure was the way to go, right? There was some other question, right?
Yeah, it's maybe a little bit specific, but I was kind of experienced this problem myself. You said you empower users by providing them very powerful UI, so they can check everything, every aspect of the model, and that's all fine. But you, at the same time, you said you have nightly builds of your model, and that requires a huge resources consumption, right? But UI is something interactive. Like when the customer make a change, and once like how you is it a problem for you, or you just show the current state of your model, and I mean, and it's not really interactive.
So
How you bridge this gap? I know it's a specific question, but
no, it's fine. Yeah, like the way we are operating is that the information that the UI is operating on is cached, and it is cached until we are ingesting. So every run is first ingesting data and seeing that the data is for the next run in a consistent state. But everything that happens between is cached and is not fed to the data or to the database right away. So when you make you can add a lot of overrides and remove overrides and interact with the UI, and it is all just cached, and it will then be transferred to a consistent state once the backend system is running the next time.
Yeah, and
so
the customer is not changing the model. It's only
Yes,
you change.
the customer's only overwriting predictions. So the model will, so in the back end, the model will put out a new forecast for the next, in the next run. But if there's an override active right now, it will be overwritten when we write it back to the customer. So the forecast will actually, in our systems, will be what the model is predicting, but the data that is sent back to the customer will be what they overwrote in the UI.
But the customer cannot trigger a model rerun or something?
Yes.
Not yet, maybe, I don't know.
No, this is not coming. Like they are very strict schedule. Everything is on very strict schedules. And we are also, I think we got this a little bit wrong, that we are not deploying every day. So the training is actually running on a much higher or larger time scale than the predict is running. So we have actually very strict SLAs, as I said, for the predict, because the customer is really expecting his predictions now, but the fits can be running for up to a week. So we have versioning so every fit is when the fit is completed, we have routines that activates the fit for the prediction. But so it's a very asynchronous work process. Yeah.
So the UI is it's powerful, but it's more on showing side, right? So
Yes.
And that makes it fast, right?
Yes.
So that PDF was before just a different format, but now it's like maybe better presented, but it's still more or less you pre-calculate everything and it stays like that.
Yes, yes.
You update the data and the customer cannot do with this picture unless, well, except of overriding the data for the next prediction run, you know?
Yes. Exactly.
More questions?
Yeah. You mentioned that you changed from file storage and stuff like that to some kind of database back and forth and so on.
Mm-hmm.
Can you explain a bit more the reasons why and so on?
Maybe it's a question to no.
So this was something that was before my time, but as far as I understand, so we have all of our data that the customer is sending that we are ingesting. Of course, we are storing it in a database. And I showed the slide. I showed the slide where we had a lot of systems running in one large evaluation over basically all the customers. So we have our processing clusters. Processing the different steps of the model, and all of these operations are querying the data from the database. If this is your single source of truth or the point where you're querying from, and when we triggered a lot of these systems at the same time, the bottleneck turned out to be the database connection. So the database was not keeping up with our demands for parallel access to our data. So what we did is, or what we figured out, is that the blob store access can actually be scaled a lot better. So we are building, we are calling those cubes. So we are querying the data at the start of our processes, of our, we call it DAGs, of our processes. We're querying the data, we are storing it on the blob store in Parquet files. So they are actually, underneath are just pandas data frames in Parquet files. And the access to this data of the calculation cluster was much more performant when we were querying the data from these blob stores and writing back to these blob stores. But yeah, as said, this has worked good for us, but it also came with some challenges because we have to synchronize the data all the time. So we have to synchronize it to the blob store, we have to synchronize it back to the databases, which is part of why we are now moving to a more capable database system, which is what Snowflake is going to provide to us now, because they are actually capable of providing us the parallelization that we are needing. This is the reason why we are moving over, so we don't have to, like large part is that we don't have to synchronize the data anymore to these, between these representations.
The key is really horizontal scaling. So traditional data database system you can't scale horizontally. They are one big machine, you can make the machine bigger, but at some point you overload it. Yeah, then came blob storage technologies where you suddenly have been able to horizontal scale your access. Yeah? Data was there once, you could scale it with thousands of computation clusters. And I think now Snowflake has taken this to the next level because they separated storage from compute, and basically you can horizontally scale your compute, what they call virtual warehouses, yeah, spin up as you like, on demand, on seconds, additional warehouses accessing the same data underneath. So you have a database system that now horizontally scales, and of course a database system with transactions, with schema management, and so on has also some benefits that you don't have if you run direct Parquet access on Blob Store, unless you build tooling on top of it. We can probably have 1 or 2 talks about this alone.
Maybe just to talk about team structure. So actually, Peter is someone who's coming from the platform side, so he's expert on this. But our teams are organized. We have the platform asset, which is another team. We have me in the data science team, but we also have an ML engineering team right next to us. So this is actually something that I'm not interacting a lot with, because this is responsibility of the ML engineering team, which is also allowing us, it's another part of allowing us to operate our system, because we do not have to care about these intricacies as data scientists. Yeah.
Okay.
An open and simple question this time. Mm-hmm. You mentioned that standardization put you forward, improved your efficiency. Can you give maybe 3 examples of what's your best case for where standardization put you forward, if you remember?
Okay, yeah, like one simple example is that we had a lot of specific implementations or custom proprietary implementations, and now we have moved to like the machine learning model is based, so the core model is completely implemented in PyTorch now. We even, in the last iteration, we had some custom implementations of some optimizers, but now we are 100% PyTorch, more or less our custom model, but using the framework as it is. Then I would say something like the move of us now to Snowflake is some form of standardization, because all of the cubes, this Parquet representations, this is also very, very much a making of our own. And a third area of...
The third one is really standardization of data delivery from the customer side. Yes. So in the beginning, each customer was able to send his custom way of the data, and each bug was different. And once we standardized on the data side, we could build data quality monitoring, a standardized UI, have basically now model evaluations across 40 customers in one go that all look similar. So this is really, and adding on top of the PyTorch story, when we moved from implementing our own algorithms with core C++ parts to PyTorch, we suddenly have been able to scale by using GPUs, because some clever open source guys really ported PyTorch to do model training on GPUs, which enabled us a factor of 10 in increasing the time that we need to train models. And that's still very much key for us, because...
Still more expensive.
Yeah, that's the other thing. No, but the key is really, if you go beyond a week of model training time, you lose velocity, because if you detect a bug, it takes another week to retrain it. And if you move it down to 1 day again, you have much better iteration cycles. And this is really something that we could never have built our own. This large-scale improvement, and the PyTorch guy or the open source guys, brilliant work. We benefit from it by adopting now standard technology that has been developed in the open source world.
You have a question? Yeah. Okay, last question.
What's your environmental impact? You do a lot of computing, so what's your environmental footprint?
So if you like, this is not my expertise, but if you believe our slides from our upper management, it is that it is environmental impact is one of our strong suits because we are a supply chain company. So like the impact of bad planning for large retail organizations is massive. Like if we are flooding some store with beer on end.
That's fine. Maybe,
There's a footprint, getting it there, and putting it back. If we have over predictions, the customers are discarding and wasting resources because they are just sometimes throwing things away that have been over-ordered. So environmental impact is actually something that we are putting on our flag as a very strong point because we are really improving the environmental impact or the environmental footprint of our customers, which are organizations like orders of magnitude larger than especially our team of this product.
So really to make it concrete, so we have the numbers, so we introduced our demand forecasting solution to Sainsbury's. That's the second largest supermarket chain in the UK with more than 1,000 stores. And once we have introduced our automated system, we reduced waste by 5 to 10% on 1,000 stores with 40,000 products. And I think this is then really a real world impact. Of course, yeah, you have the compute resources, but this is then really, and it goes down really to reducing meat waste, where if you think it a little bit further, it's really killing animals for nothing. So, of course, that's now the marketing slide that I provide to you. But I think there, I think we all have some real world impact.
Wonderful. So, yeah, thanks, Jakob, for the great talk. Thanks for the questions and answers. And now we come to the next. Now, what's next? Oops.
Lightning talks.
Lightning talks, right. Lightning talks is next. And let me just announce the lightning talks.
And feel free to get another.
Yeah, we have 30 seconds.
Or just raise your hand and say beer, then I bring some beer.
I'm raising a glass.
Oh, okay. So,
Dankeschön.
okay, you have 60 seconds.
Toilette ist gerade links rum. Wenn du eine mit Waschbecken haben möchtest, musst du eins höher gehen.
All right. High demand of drinks, so we're going to start with lightning talks in a minute. Das wirst du nach meinem Talk beurteilen können. Profi. Alright. Schau ich die mal wieder rein. Bitte. Hopp, hopp. Lightning Talks. Ja. Alright. All right, let's start with the lightning talks. We have 3 lightning talks today, one by Rustam, a glimpse into causal reasoning with LMM. I'm going to give a lightning talk about Python Excel, whether it's hell yes or hell no. Not spoiling anything. And we have Gavin talking about Python Barcamp in Karlsruhe. So, Rustam? Yeah, it's getting a drink. Yeah, thank you. That's very good. Okay, it's you're up now. All right. So 1 minute zum Mikro geben. Yeah. So we're getting ready for the first lightning talk. And here you go.
maybe
One question, who knows lightning talks? Who doesn't? Ah, okay. So lightning talks is just like you can talk about 5 minutes about everything which is basically appropriate, but you have exactly 5 minutes and there's no Q&A afterwards. Yeah? And the talk will end after 5 minutes no matter what. Okay, here you go.
stop.
Oh, it's 4 minutes now.
Yeah, before I start, I wanted to share a very small story about Blue Yonder. So it was 2014-15. I was working as the research assistant at KIT, and I was part of a very small team, MRT Institute, Messungsregulungstechnik, and we were working on the image processing algorithm for the autonomous driving. And we started to hear about this deep learning, machine learning, and it was kind of a first tryout to do it. And then we're hearing about Blue Yonder, who is not just for years already selling the machine learning solutions, but already hiring some people. And for us, it was like a big aha moment. So thank you guys, you're one of the pioneers. And it's a pleasure to be here today.
Okay, great.
I start?
So, we are starting now.
My name is Rustam, I'm a founder of Black4 AI, and today let's talk about the causal reasoning. So majority of the businesses that we are having today, whatever the industries are, they are dealing with unstructured data. Yeah, so, and it's representing about 80-90%, so officially it's 90%. And we're talking about, this is basically the data flow, and on the level of the data collection, processing, this is like the problematic area with the highest level of complexity and, however, highest level of the automation required. And if we are talking about the LLMs, how can we implement it here, not just to deal with the unstructured data, but also to deal with this dynamics, because we're living in the big data age, and data is in motion. We have two opportunities, basically. We can continue to fine-tune our LLM, big foundational model, in order to deal with those dynamics of the data, but we have two problems here: cutoff dates and the catastrophic forgetting. Catastrophic forgetting is every single cycle of the fine-tuning brings this negative opportunities that one day your model will start forget some critical parameters. However, another way how you can do it, and this is majority of the businesses, they're working on this solution, so-called the RAG, Retrieval Augmented Generation. This is the next slide. We will talk about it, but at the beginning, essentially here are two issues: retrieval sensitivity, which is basically your retrieval system or the algorithm, which is very sensitive how it works, and it requires the know-how how to do the instruction tuning back to your LLM. This is the knowledge management, the one part, how it looks like. You have your LLM, you have your RAG, whatever the corpus of data you are dealing with, and you are connecting it. Yeah, it could be observational data, experimental or selection bias. Basically, you have a query. You need to have the causal model. This is a lot of machine learning people now start to understand, because all of the processes are always different compliance, different domain knowledge. You need a causal model representing the process or the data generation process. And then basically you have the LLM, whether it's fine-tuned, instruction tuned, it depends on the business itself. What we do at Black4 AI, we're concentrating on the reasoning, basically concentrating on two parts to identify the cause-effect pairs in the data that the LLM delivers through the RAG, and cross-task generalization. So basically, it's on this slide, on this side, but in reality, our solution is also part of the RAG system. So why we need, in general, reasoning? So here it's two examples, ChatGPT. I'm pretty sure all of you heard about this. And basically, in average human intelligence, human capability. So-called the formal reasoning, it's logic, just the logic. So it's being estimated so that the ChatGPT at its best on different kind of the synthetic data cannot achieve 40%. We humans at let's say at the average, we are already more than 50%. And this is a technical representation how the LLM does inference, and this is all of our capabilities as the humans, because we have sensory information, ears, eyes, and of course, we are much more advanced in terms of the perception. And here you see, yeah, maybe 2 examples, ChatGPT and the best of Germany. Aleph Alpha, by the way, Jonas, I told you you need to work with us. This is not good. So 2 areas, 2 benchmarks, common sense, where the ChatGPT, GPT-3 achieves 61%, and Aleph Alpha, unfortunately, only 11. This is so-called the chain of thoughts prompting technique, and we're talking about the F1 score. And here's the ground truth. Ground truth means so that we are introducing the causal graph, which should help, but in reality we see it's only almost 50-50 chance to get the accuracy. So it's not acceptable by the business, basically no reasoning in practice, and yeah, supervised learning still #1 choice. Thank you very much.
Whoa, very good. Yeah, thanks a lot for the talk. You have 10 seconds left.
Thank you, guys.
All right, we come to the next lightning talk, which is actually by myself. So. Yeah, thank you. So. See if it fits. Yeah. Very well. So, okay, can you do the timer, please? So, and I will start now. Okay, this is at least a 10 minutes talk about Python in Excel. So, hell no, or yes. As you know, Python is now part of Excel. So, you know me, you know Königsweg, Python Excel. So, Python Excel is actually nothing new. There has been Excel wings around to interact with Excel from Python code, doing amazing speed-ups and whatever. So this is not new, but the very new thing, which is probably very hyped now, is Python within Excel. You can open Excel and just type Python in your Excel cell, and you don't need to set up an environment. And this is basically not a bad idea, because so many customers of our day really don't get how to set up Python environments, and we have to, I don't know, one solution to make it easy for regular people to manage environments if you don't do it on a daily basis. It's still like an ensemble problem. Yeah, so environments are black magic to many. So the idea to have Excel here, you can just like insert Python, use some data, put it there, and then you have this add_py function, and you can create a pandas data frame. Yeah, as you already see, you have like a beautiful code completion here. It's like writing text, and the people are actually like you can do directly analysis on the data you have in your Excel sheet with pandas. Pandas is built in as matplotlib. You can write a lot of code. If you watch what people suggest on YouTube, you can, ChatGPT can write the code for you. You just put it here. And so, yeah, you see, there's batteries included, pandas, matplotlib, stats models, numpy, seaborn. So, okay. So I was said, okay, technically this might be impressive, and it was done by Microsoft and Anaconda actually. You can do more, so there's, this is everything that I mentioned is imported here, and you have access to a data frame, but actually like it has like a very unique calculation logic. So if you have a data frame here, you can reference it from left to right and from top down, which is straight, because if you want to reference it over there, it will be not known. That is pretty strange, and this is like how I feel about these things. But I said, okay, let's not just ask my bubble, so I asked Twitter, like not only my Twitter bubble, so like a bubble, so hey, Python Excel, what do you think? I did that in August when it was basically new, and basically I was really concerned, like hell yes and heaven is the majority, and there seems only be like 17% of people said hell no, and I can now spoil, I'm definitely with the hell no people. Why? Because although this enables a lot of people, like Python Excel, like that's the verdict. So this is like how the distribution of the sizes of the communities of programming languages. So there's like 15.7 million Python users estimated, that's from Statista, and Excel basically enables now 70 750 million Excel users who are out there who can now also be Python users. So this is good news for Python, as you can see, because we're now dominating everyone. Like, yeah, but then Python and Excel, you have to see, yeah, it's okay, yeah, I mean, this is ugly. I mean, you all know there's VBA code, there's macros in Excel, yeah? There's all this, like, shadow IT going on already, and it's a big mess. Once you start a data project, it's a big mess with all these tools. And it's not really good. I don't see any reason this is a bit better to maintain than the other crap we had before, I'm sorry, yeah? And anything beyond simple, yeah, I mean, I think it's okay to enable users who just want to do some quick and dirty analysis within the Excel sheet. I don't mind that. I think that's a great feature. But anything beyond simple is basically legacy once you push enter. And there's more, yeah, but it works on my Excel file, we will see that. And you have basically zero reusability, yeah? And there's more danger zones, because what about type safety? I mean, there's pandas. Pandas will just pass the data, and Excel users are very sensitive to data quality and missing data, and how will they handle that? And also like security issues, because actually Python code is not executed locally, it runs in the Microsoft cloud. So, and yeah, so this is probably not even admissible for many. And yeah, debugging, I think debugging will be really fun within Excel, Python in Excel, because Excel sheets debugging is already fun. And as I mentioned, yeah, it does not offer any solution for fundamental data problems. And I want to close to the 50 million Excel users now able to use Python with good luck. Thank you. And this brings us to our next lightning talk. So, where are you? Here are the lightning talks. Going? Are you ready? All right. Here you go. And you also need this.
Okay. I don't prepare any slides yet, because we introduced the Python Barcamp Karlsruhe on Friday, so it's quite a few days where we announced. But I'm happy to introduce to you the Python Barcamp Karlsruhe will take place at the DHBV, which is only about 700 meters in this direction. And it will take part on 23rd and 24th of March. And I'd like to invite you to this barcamp. There will be a lot of topics about Python and something like this. Do you know the format barcamp? You already take place in one. Maybe a little introduce what a barcamp is. A barcamp is it's a place where the topics are generated by the group. We are getting together and choosing and planning our sessions at these days. Yeah, and so I'd like to invite you. We will be there, and the organizers are a friend of mine living in Magdeburg and me. Yeah. I will be very nice if you like to join us. Thank you.
All right, thank you. And really thanks for organizing. I'm really happy to see Python Barcamp happening in Karlsruhe. And so, yes, final announcements. So, oh yes, final announcements without any. Okay. Bye bye. Bye bye. Hello, projector. Hello. So. Yes. Okay. Where were we? We were here, right? Yeah. So yes, if you haven't, we have a LinkedIn group also for announcements and stuff, and we have a call for speakers. So if you're, did you like the talks today? Woo! Oh. All right. So This can be your stage as well to talk about your topics, anything you want to share. Don't be afraid to see, like, it's a really forgiving, funny, and welcoming community. And I think if you really want to learn something, give a talk about it. And you would be surprised how many renowned speakers basically give talks about something they're just learning, and you wouldn't notice from their talks. Yeah, also, if you want to contribute a 5-minute lightning talks, okay, just go to, there's a web form, you can just throw your ideas there, and we will get back to you immediately. The next PyData will be in Heidelberg and at the 5th of December at Heidelberg Materials, formerly known as Heidelberg Cement, but cement is probably not so fashionable anymore, so it's Heidelberg Materials now. Yeah, so see you there. And also, yeah, and then 24th of January, Heidelberg. Your turn. Also, give us feedback, contribute lightning talk or talks. Yeah, you can host and sponsor us, rate this event on Meetup, reach out if you have any questions. And yeah, thanks to Sebastian and Peter for hosting, Blue Yonder, of course. Thanks to the speakers, Johannes and Jonas. Now, Jakob. Sorry, I'm sorry, not so good names. Yeah, and yeah, and I think that's it. So yeah, oh yeah, here. Oh, good. Sure. Yeah. Okay, and Kevin for video ops, of course, and Sebastian for Q&A. I didn't know that when I put the slide. So XX. So yeah, and that's it. Thank you. Thank you.